Hello, I am William Lofton and I'm doing the video portion of our NAA Grand Challenge project. For our project, we decided to choose infrastructure, specifically bridges. Now, one of the reasons why we decided to choose bridges is we looked at the grading for infrastructure, and in the US as a whole, our infrastructure gets a D from the Society of Civil Engineers. And bridges in particular get a C+, as you see here. Now, some of you maybe on your test might be happy with just getting the C+, but do you really want to be driving over these bridges with just a C+ grade and only, and as time goes on, they're going to be deteriorating, and we wanted to look at how much it costs and to make these bridges with the raw material that we have for different types of bridges. And so for this challenge, I wanted to go over what we were trying to do specifically. I wanted to give us a quick summary of our challenge and what we were doing. So the challenges to restoring and improving the urban infrastructure are numerous. Restoring the urban infrastructure itself can be very cumbersome due to the load of work, the time that is required to finish the construction without mass destruction in the future, and specifically the money required to do so. And so our group wanted to look at the role that engineers play in coding and solving the problems correctly in order to calculate the cost of the raw materials for bridges, and specifically bridges built for their specific states and their specific areas. So now I'd like to cover kind of the summary of our problem statement. So our goal was to do a calculation of the average cost to build a bridge in the state that the user has chosen with certain materials. We'd also wanted to determine which state has the most efficient built bridges, looking at the total cost to build the bridges with certain materials. We also wanted to compare the US total average of bridges for each material to the selected state's average of bridges of the material. Now, before I get into the code and everything, I wanted to run down kind of the outline of the algorithm so that you're familiar with kind of what's going on before you even see it, and so you maybe get an understanding of what we're trying to do specifically beyond just the words I've said about calculations and comparing averages and whatnot. So for our knowns or inputs, we're going to have user inputs, and these are going to be the state, the amount of land area you want to use, and this will be in square feet, and what material you want your bridge to, what material you want to create your bridge out of. For our unknowns or our outputs, we're going to get the amount it's going to cost to build a bridge with that material, the US total percentage of bridges for each material versus the total percentage of bridges for selected state by the user. For our assumptions, we have the cost for the material that we're using, and the material that we chose is concrete, steel, pre-stressed concrete, aluminum, wood, and masonry. For other variables, we have the total cost, which is equal to the amount of land area times the average land cost of each state times the cost of selected material. Our total bridge is equal to the sum of all bridges. We're also finding the percentage of bridges for each material of US, which is equal to the sum of the bridges of each category in the US divided by the sum of all the bridges in the US. We're also taking a percentage of the bridges in each state, which is equal to the number of bridges in for each category divided by the sum of all bridges. Now, to specifically hit the algorithm, I'm going to just go over the basics of the code before I run it. And what want to go over the input variable specifically. So here we have S, which is equal to the state that the user wants to input, for instance, Texas. LA, which is the amount of land area the user wants to use in square feet. And M, the material that the user wants to utilize to build the bridge. For our intermediate variables, we have CC, which is concrete cost, SC, steel cost, PSC, pre-stressed steel cost, AC, aluminum iron cost, WC, wood cost, and MC, masonry cost. Obviously, for the beginning of our code, like any other, you have CLC and clear. For our intermediate variables, CC, as I mentioned before, these are all the costs that we input. So $4.99 for the concrete per square foot, $105 per square feet for the steel cost. For the pre-stressed for the pre-stressed concrete, we have $125 per square feet. For the aluminum cost, we have $5.45 per square feet, and for the wood cost, we have $56.23, and MC, which is the masonry cost, is $14.35. This material cost just takes all of the materials that we put up above and puts it into a matrix right here. After that, we then import the data into another matrix using the XLS read. For a title, we use fprintf to create a simple title, which you'll see in a moment. Then we have our user inputted values, as mentioned before. S is our input for the state. LA again is the input for land area and square feet. This while loop here checks if the land area is less than 0. If it is less than 0, you'll have to re-enter the land area. This M here is ask you what type of material you want to choose. Again, we have concrete, steel, pre-stressed concrete, wood, masonry, aluminum, iron. Right here, the match, where it says match is equal to string compare I. This is where we can compare whether or not the user inputs capital letter for Texas, capital T for Texas, or a lowercase t. Whether or not they input lowercase or capital case t, it will not matter. Then here we have our determination of the material and the actual cost for the average land cost for each bridge and its material, depending on the state. So we take out the type of state, we take out the material cost depending on which material it is, and we go through each one. So say you're doing concrete, you would get 1, or if you're doing pre-stressed concrete, you're going to get 3, and then it just calculates, it goes through and it calculates everything for each one of our states and how much it would cost for that land area to build a bridge with that type of material. Going on to the next portion, it does a similar type thing. This is the specific material cost. It does a very similar thing with our if statements, depending on whether you select a different type. It gives you specific material, whereas above we were calculating the land cost. This just gives you the material cost. Here we have conversions of the average land. Our land from our data was in acres, and so we had to convert it to square feet. Here we're doing the calculation for average cost. the cost of the material times the land times the average land cost for that state. Here we sum the total number of bridges in the US. Here we're doing the calculation of the sum of the total number, the calculation of the sum of total number and percentage of bridges of each category in the US. So this is getting the total number percentage of bridges compared to the number in the US. This is the total number of bridges compared to the number in that state. We used if statements. I should mention that with these different if statements, if you're not selecting if you not choose a material, it's going to prompt an error and end the code. I forgot to mention that as I was going along. All of these calculations with material costs and calculations for percentages will give you an error if you do not select a particular type of material. Down here is our if statement telling us if the percentage is greater than the US. We give the difference. If it's not greater, then we give the US difference compared to the state. And then we have our printf statements down here, which are telling us the different costs and the different percentages. And finally, we have the percentage of the state compared to the percentage in the US. And lastly, we have this menu, which will bring us back to the top if a user wants to select a new data set, which is this while loop, which is going through the whole part of the code. Now, I'd actually like to run through the code because it's probably a bit confusing to see all of the different numbers without it seeing exactly how this runs and works. So as you see, I told you before, there was a title that pulled up, and then it prompts us, which state would you like to choose? So I'm going to type Texas, but with a lowercase. And it pulls out the data for Texas, and now it asks how much land, and we're going to do 1,000 just to make it simple. And now it asks me what material I'd like to make my bridge out of. So I'm going to select steel, and here we have it. So it says that it'll cost us about $4,676.31 in terms of materials and land to build the bridge. Now that's just raw materials. That doesn't count different types of parts in the bridge or the labor cost. And 1,000 square foot bridge is pretty small, so it's very reasonable to get that cost for that size of bridge. It says that Texas consists of 8.2% of steel bridge. The US consists of 27.9% of steel bridges, and there are 19.7% more percentage of steel bridges in Texas than the US as a whole. So now it asks for if we like to enter a new data set, so I'm going to say yes. And I'm going to enter, let's say, Washington, and we're going to do a capital just to show that both capital and lowercase work. Now it wants me to enter the land area, so let's say 20,000. All right, and we're going to go with aluminum iron. And so once again, it brings up. It looks like it'll cost about $17,789.26 in terms of materials and land to build this bridge that is 20,000 square feet. Washington consists of 0.3% of aluminum iron bridges. The US consists of 0.4% of aluminum iron bridges. And there are 0.1% more percentage of aluminum iron bridges in Washington than the US as a whole. So now let's say we want to enter it one more time just to confirm that we're getting what we would like to get. So I am going to enter California, and I'm going to enter 100,000. and I'm going to select concrete, and we get our data set again. So it looks like it's going to cost $88,207.07 in terms of material and land to build the bridge. Now again, that's just raw materials. That doesn't count for all the labor and everything. We're just trying to look at raw materials. What is the outlook for a bridge in a kind of general fashion? California consists of 49.2% of concrete bridges. The US consists of 39% of concrete bridges. There are 10.2% more percentage of concrete bridges in California than in the US as a whole. So now if we've entered all the data in that we want, we can go ahead and hit no. And that while loop was working the way it should. We hit no, and that is 2. And so when it went back up to the while loop, it was not equal to 1, and so it exited out. All of our code is bringing up exactly what we are looking for by entering in the states and the calculation. So in conclusion, one of the things we found is that raw material is not the most expensive portion of the bridges, but is a very important part of what you need to make a bridge out of and how you're going to do so. So hopefully you enjoyed learning about our project, and thank you.